Welcome to the final lesson. Usual routine, have a go in your own time. Okay, the answers to this are y equals 0, or y equals minus 11, or minus 11th, sorry, or y equals minus 1. Let's look at y. One equation, three different unknowns, because remember, y to the 5, y to the 4, y cubed behave differently, they are different objects. But maybe we can use the trick, which is that we turn it into we factorize it, so it's a bunch of things multiplied together. How do we factorize? The first thing is we try and find something they've all got in common. Oh look, they've all got a y cubed in common. Let's take that out. So we end up with 11y squared plus 12y plus 1 equals 0. Then the second, we then repeat that stage. I can't see anything else. Now we try and do double brackets. So, I mean, the y cubed is already done, so we should leave that. Now we try and turn the rest into double brackets. Oh look, the only way of making plus 1 is to have 1 times 1. I mean, it could have been minus and minus, but it clearly isn't that in this case. Then to make the 11y squared, we have to split the y up. And, oh, 11's a prime number. There's only one way of doing that. It has to be 11 times 1. That's it. I mean, you can, if you like, you can multiply that out to check that kind of thing. I'm not going to do that here this time. We've got three things multiplied together that make 0, which means one of these three things has to be equal to 0. So either y cubed equals 0, 11y plus 1 equals 0, or y plus 1 equals 0. Oh look, if y cubed equals 0, well then basically y is 0. If 11y plus 1, that's minus 1 from both sides, that gives us 11y equals minus 1. And then if we divide by 11, oh look, we've got that answer. And this one here, we minus 1, y equals minus 1. Oh look, we've got that answer. Let's do the next question. It's another solve. What a surprise. What a surprise. Have a go in your own time. And the answers are x equals 0, or x equals minus 9, or x equals minus 1. Okay, we've got three different objects, an x cubed, an x to the 4, and x to the 5, x to the 4, x to the 3. Therefore, in theory, can't be done as only one equation. But it looks like a good candidate for the trick, doesn't it? Where you kind of factorize to make it into a bunch of things multiplied together. But for that to work, it has to be equal to 0. So let's add 9x cubed to both sides. Because remember, that trick only works if you've got a bunch of things multiplied together. In this case, I think it's going to end up as 3. If it's a bunch of things multiplied together that make 0, the trick works. But it has to be equal to 0. Okay, promising so far. Now let's try and factorize it. So the first thing we do is to try and take something out. I'm going to spot that we can take x cubed out. I'm just going to role play it here. I'm going to say, oh, I can see an x. So that's x to the 4 plus 10x cubed plus 9x squared. Now I have to repeat this step. Oh, I could have taken more out. Actually, I could take out a whole another x squared, so that makes x cubed. So remembering the importance of returning to the steps, check you haven't missed anything. And then, if once you're sure you haven't missed anything, then we try double brackets. The x cubed just sits outside anyway, that's already done. Now we try and factorize the rest. There's only one way of making x squared, x times x. How are we going to make the 9? Well, you can experiment with this, but ultimately it's, whoops, it's not that. Ultimately it's 1 and a 9. So let's now identify that we've got three things multiplied together make 0. Therefore, one of them has to be 0. So either x cubed equals 0, or x plus 1 equals 0, or x plus 9 equals 0. If x cubed equals 0, obviously x equals 0. Let's minus 1 from both sides here. That makes x equals minus 1. Minus 9 from here, and that makes x equals minus 9. That gives us the three answers that I mentioned earlier. Let's do the next question. Have a go in your own time. And the answer is not possible. Why? Well, suppose we minus x from both sides. Let's just do that, let's just tidy things up. Oh wait, that means you've got x minus 1 minus x equals x plus 1 minus x. And just to absolutely spell this out, there's a plus in front of that and a plus in front of that. So we've got a plus x and a minus x, so they cancel on the left. We've got a plus x and a minus x, they cancel on the right. So we've now got minus 1 equals plus 1, which for starters is impossible anyway. So that's a whole different issue. And anyway, clearly this equation gives us no information about x, so we cannot solve to find out where x is. Not possible. Now solve this. So let's do something kind of a bit similar. Just to kind of compare and contrast. The answer to this one is x equals 2, so this one actually is possible. This one, we're going to minus x because there's more x's on the left-hand side. So let's tidy up the x's on the right-hand side. So we'll minus x and that gets rid of them. So then we've got 2x minus 1 minus x equals x plus 1 minus x. So these two cancel. These combine, so that gives 2x minus x just makes x. Now I'm going to plus 1 to both sides because I'll need to get rid of this minus 1. So x minus 1 plus 1 equals 1 plus 1. Oh look, they cancel. X equals 2. Boom. There we go. We've shown that. Next question. Have a go in your own time. The answer is going to be x equals 5. I'm going to do this by inspection. So I'm going to start off by trying to make it look this. I'm going to start off trying to make it look the same. How can we make this look the same? I'm going to write this out like this. Oh, well then by inspection, that x has to be equal to root 5 times root 5. So x equals root 5, which is equal to 5. Let's do this one next. I'm just going to write this neatly, I just want to make sure it's clear. That's x to the power n equals 25. Have a go in your own time. The answer is not possible because there's two unknowns. There's an x and there's an n. So for example, maybe it's 5 squared, or maybe it's like 2 to some weird power that's somewhere between 4 and 5 or something like that. Anyway, but the point is, it could be anything. There's two unknowns, only one equation. So not possible. That's it. End of question. Next. I'll tell you when I've finished writing this one. And I've finished writing. That's it. Have a go in your own time. The answers are going to be x equals minus 2 and y equals minus 4. So if x equals minus 2, y is minus 4. Or x equals minus 3 and y equals minus 9. So those are the answers. Now let's look at how we get them. Well, oh look, that's a y. We already know what y is. So let's take this equation and then put this other one into it. So we've got x squared plus, and then I'm going to write 5x plus 6 equals 0. So just to spell it out, this comes from here because I know that's the same as y. Let's carry on. Oh look, this is easy. X plus 2, we've done this a million times. X plus 3 equals 0. So run a line down, x plus 2 equals 0, x plus 3 equals 0, minus 2 from both sides, x equals minus 2, boom, minus 3 from both sides, x equals minus 3, boom, which gives us that one and that one. But then we have an equation for y. So if x equals minus 2, then we can say y equals 5 times minus 2 plus 6, which is minus 10 plus 6, which is minus 4. Ta-da! So that explains that one. And then if x equals minus 3, y equals minus 3 times, okay, trying to go fast here, 5 times minus 3 plus 6, which is minus 15, plus 6, which is minus 9. There we go, we've explained that one. Let's do the next question. Okay, I'll tell you when I've finished writing. Have a go in your own time. In theory, this isn't possible, but just because there's like added complications, but basically we can work out what this means in the context of we're doing simpler questions in this series of lessons. And this feels kind of appropriate to the level we're working at the moment. Blah, blah, blah. The answer is k plus 2. Because, oh look, we've added 2 to go from 1 to 3, and oh look, we've added 2 to get from minus 13 to 11. So from k, we add 2, and we end up with k plus 2. And traditionally, you might see this as written as f of x equals x plus 2, because we often use x, don't we, when we're talking about variables. But for this question, I decided to use k. Let's do another one. Right, I'm going to do a calculate, and there's a warning, which is only if answer is an integer. My point is, if the answer's like really awkward, don't do it. We're just doing the easy ones. I'll let you know when I've finished the list. All these are supposed to say 64, by the way. I realise my writing is a little bit scruffy at times. Have a go in your own time, then I'm going to write the answers. 2. Not possible. Not possible. 4, 8, 64. Move on if you're happy. Does this actually exist? I don't know, but I mean, you see what I mean. I'm getting used to the idea of having different types of root. This is not possible given that we said it has to be an integer. Okay. Similarly, this is not possible given the fact that it's an integer. And just a little thought is, examiners love using this pattern because they love the fact there's 3 different roots of 64. So you often get like weird questions which use the number 64 because there's this pattern, which means that you can easily give answers that are integers. I'll let you know when I've finished. There's a bit of a list. That's it. Have a go in your own time. Pause the video, blah, blah, blah. 1 over 36. Oh, that should have an equal sign, shouldn't it? 2 over 9. 1 over 18. Happy? Move on. Otherwise, watch. That is 1/6 times 1/6. Because that's what times mean. And when you times the tops. So 1 times 1 is 1. You times the bottom. 6 times 6 is 6. So makes 36. This one, you've got 2 times, and then 1/3 squared is 1/3 times 1/3. I'm just going to immediately do 2 over 1. So I can add just 2 times 1 makes 2. So I just run all the way across the tops, all the way across the bottom. 1 times 3 makes 9. There we go. That gets the answer. Exactly the same thing here. I've got a half times a third times a third. So a third times a third because that's what's being squared. 1 times 1 times 1 makes 1. 2 times 3 makes 18. Ta-da! There we go. Next question. Again, some calculates. I'll let you know when I've finished writing them out. Take your time. Oh no! Oops. Oh, there we go. Right. Answers. 1 times 1 times 1 equals 1. This one's going to be 1/3 times 1/3. 1 times 1 is 1. 3 times 3 is 9. This one, we flip it first because of the minus. That makes 3 over 2. We've still got the square to do, so we've now got 3 over 2 times 3 over 2. which is 9 over 4. This one, oh, what does the 3 on the bottom mean? That means a root, so that must mean the cubed root of 8, which is what number, which is 2, because that means what number times by itself 3 times makes 8, and the answer to that is 2. Let's do the next question. Do another calculate. There's just one here, but I'll let you know when I finish writing it, because there's a couple of bits to it. Have a go in your own time. The answer is 3/4. And the reason is we have to do the order of operations. So the first thing we do is the times. So it's going to be a half plus, and then 1 times 1 is 1. 2 times 2 is 4. And then we can say, oh, well, I'm going to multiply the top and bottom of this by 2 because I want to make the fractions the same. So I can add them together because I can only add together things that are the same object. Oh, look. And 2/4 plus 1/4 makes 3/4, much like 2 elephants plus 1 elephant makes 3 elephants. Next question is going to be a solve. Have a go in your own time. My answer is m equals 8. And I'm doing that by inspection. I think it's fair enough to do by inspection here. Because you can just say, oh, well, it's just asking me the cube root of what number is 8? Is 2. Well, that's 8, isn't it? So there you go. I'm just gonna hang around here for a second because I realised maybe that was just a bit glib. Just remember, I kind of try and remember these. What's the cubed root of 125? 5. What's the cube root of 64? 4. What's the cube root of 27? 3. What's the cube root of 8? 2. What's the cube root of 1? 1. So there's a few like key numbers I just try and keep in my mind just because they're useful, because they crop up so often. I'm going to do a simplify if possible. I'll let you know when I've written them all because there's a bit of a list. Have a go in your own time. The answers are x to the 5, not possible, not possible, and 1 over x. Skip to the next question or hang around while I talk them through. This is x times x because that's what x squared is. Then x times x times x is x cubed, and clearly that is 1, 2, 3, 4, 5 x's, so that's x to the 5. An x squared is different from an x cubed. You can't combine them. They're two different variables. Not possible. An x squared is an x cubed. They're two different types of variable. You can't combine them. You can't take them away from each other. Not possible. Oh, divide just means turn into a fraction. So we can do that. Which gives us that. I'm just going to write it out fully just so I can see what's going on. Okay, so I could cancel those. And remember, when we're cancelling divides, we have to leave a 1 behind. So the answer is 1 over x, because that was what was left afterwards. Okay, so that's correct. This is the penultimate question. Plot. Nah, we can't be bothered. We're going to do sketch. But remember, with sketch, what's the important thing we do? Y equals x. Y equals x squared. Y equals x cubed. Y equals x to the 4. Y equals x to the 5. Y equals x to the 6. You might not want to not pause because I've got to draw some axes now, which is going to take me a while. Y, x, 0. Y, x, 0. X. Y, 0. X. Y, x, 0. Y. X, 0. Y. Okay, ready? I'm going to do the answers in red. I'm drawing the answers now. Y equals x. Y equals x squared. Y equals x cubed. Y equals x to the 4. Y equals x to the 5. Y equals x to the 6. Happy? skip to the next question, otherwise I'm just doing a little bit of explanation. Remember, we could do, for say this one, we could do, what if x is 1? Y is 1. What if x is minus 1? Y is 1. Oh, that's why it curves up like that. But for the cubed, what if x is 1? Y is 1. So that's that point there. But what if x is minus 1? That's minus 1 times minus 1 times minus 1, which is minus 1, which the first bit, I need a new colour, the first bit makes 1, which means the answer is actually minus 1. So that's why that point goes there. And the pattern continues with even powers and odd powers. Last question. One more sketch. And then there's going to be one more like tiny video, which will be like, what could you do next after finishing this course? Which is going to be like me chatting briefly about just some thoughts about where you can take your studies. I'm going to draw the answers on in green. If you're happy, that's the end of the video. Otherwise, I'm going to do a little chat. This is like the graph y equals x, but with 3 added. And it's the y. Remember, the equation says y equals x plus 3, so we're adding 3 to the y value. So the y value is increasing by 3. The x value doesn't change, but the y value increases by 3, so it gets lifted up by 3. Same thing here. This is like the graph y equals x squared, but the value of y has 5 taken away from it. And therefore, effectively, every single point is lowered by 5, which means the whole graph shifts down by 5. Thanks for watching.